Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the insertion and deletion of data to and from strings. One of the advantages of the many dialects of BASIC, and PowerBasic in particular, is the ability to do string handling. Today we're going to be looking at methods for inserting and deleting text from inside strings. So first of all, we will create a local variable and we will populate it with a string. So here we have our local variable, data, containing a string of text. This text is in 2 lines and contains the word Monday. What we're going to do is replace the word Monday with the word Tuesday. And we're going to look at 3 different mechanisms by which we can achieve this. So we will first create a new variable called newData. This is going to contain the content of our amended string. And we will create another variable called target. This is the target string we are looking for in our data variable. When performing this type of replacement, one of the common ways of doing it is to use the replace command. As we're going to be creating 3 different ways of replacing this text, we're going to embed these 3 different methods in 3 functions. So our first function will handle use of the replace command. And we will call our first function replaceDay1. It will take 3 parameters: the data string that we wish to amend, the target string we are looking for, and the replacement piece of text we want to slot in to replace the word Monday. We will create this new function in a moment, but once we've actually processed and populated the new data variable, we want to print the result out to our screen. So let's create that new function, replaceDay1. So here is the skeleton of our new function with its 3 parameters. So we'll create a local variable called amendedData, which will contain the data we've passed in. And now we will use the replace command to replace the target string with our new day string within this amended data variable. Using the replace function is a very straightforward way of replacing a string within another string. And at the end of this function, we're returning the value of the amended data variable. If we look back at the data string, we can see the word Monday only appears once. One thing to be wary of when using the replace command is it will replace every instance of the target that it finds within the string. In this case, the word Monday only appears once, so it's good to use the replace command. If the word Monday appeared more than once, using the replace command would replace every instance of Monday with the word Tuesday. So the fact that replace will replace every instance of the target is worth remembering in your own code. In order to determine which of the 3 methods of replacing this string are the most efficient, we're going to be using a timer. And because the Windows operating system could be busy doing other things when our function actually runs, we want to run the function multiple times, and we'll take an average of the length of time it takes to run the function. So we're going to create some more variables: a timer for our CPU cycles, a loop number, and a number of loops. And we're going to set the number of loops at 1000. So we're going to call this function 1000 times. And we will wrap the call to the replaceDay1 function inside a for next loop. So before we start the loop, we're calling the ticks command, giving it the single parameter of the quad variable we're going to be populating. We'll then run the loop 1000 times, calling our replaceDay1 function, and once the loop has finished, we will end the ticks command, again populating the timer. This will give us the number of CPU cycles that this particular function has taken to run. And we will now create a print result function to print the value out to our log. So let's create this new print result function. So here is the skeleton of our new function taking its 4 parameters: the data, the value of the timer, the loops, and the type we're actually doing. In this case, this is going to be the replace command. And we will print this out to our log so we have information on how long the function took on average to run. So we're using the format command, and we're giving it the value of the timer divided by the number of loops. This division symbol here, as opposed to the normal one, will give you a whole number. So if we try running our application now, we will see we have the value output, and it has successfully replaced the word Monday with the word Tuesday, and it has taken 1,336 CPU cycles to run on average. So this is our baseline using the replace command. So now we're going to use a couple of new commands, strDelete and strInsert. And we're going to do this in exactly the same way. We're going to do a for next loop, and we're going to call a new function called replaceDay2 with 3 parameters as before, and at the end of the loop, we're going to close off the timer and print out the results. So let's create this new replaceDay function. So here is the skeleton of our new function with the 3 parameters as they were before. We have again created a local variable called amended data and populated it with the data that's come in on the parameters list. Rather than doing the code on a single replace command this time, we're going to use 2 separate commands. First of all, we're going to work out what position the word Monday exists at, and we can use the inString command to do that quite successfully. This will return the character position where the word Monday begins. As our data only has the word Monday once, it will find the first instance of the word Monday. If the word Monday appeared twice, it would still find the very first instance. So this function is ideal where the word Monday appears more than once and you wish to find the very first instance of it. So in our amended data variable, it contains the full text containing the word Monday. First, we're going to use the strDelete command to delete the text from that string. The strDelete command takes 3 parameters, the first being the variable that contains the text that we wish to amend. The second is a numeric variable which holds the position where this text starts. That's followed by the length of the text we wish to replace, so we can use the len command to work out how long our target string actually is. After this command executes, the amended data variable would no longer have the word Monday in it. It would be removed completely. Now that we have removed the word Monday, we now want to insert our new data, in this case the word Tuesday, and we want to insert it at exactly the same position. So to do that, we're going to use the strInsert command. And the strInsert command takes 3 variables, the first being the variable containing the string. The second is the value we wish to insert, and the final variable is a numeric variable containing the character position that we wish to insert to. This will insert the data at that position and move all text to the right of that position further to the right. And all we need to do to finish this function off is to return the value of the amended data variable. So having completed that, let's try running the application now to see how long it takes to run. And there we have the run of our replaceDay2 function, handling the delete and insert commands. As you can see, the average number of CPU cycles is slightly lower than that used using the replace command. Remember, this is running each of these functions 1,000 times. So let's now look at a third way of replacing our text. So we're now going to use the string append approach. Again, we're taking exactly the same way of doing our loops. We're now calling a new function called replaceDay3, again passing the same 3 parameters. And we're using the print result function we've already created to print out the results. So let's create this new function. So here is the skeleton of our new function, again taking the same 3 parameters. We've again created a local variable called amended data, but we're not initially populating it. As we did in the previous function, we're first going to get the position where our target string exists in the data variable. Having got that, we're now going to look at populating the amended data variable. And we're going to use two other string functions, one called left and one called mid. The left $command will give us the string up until the start of our Monday word. We will then add on the value of the new day, and we will tack on to the end of that everything to the right of our Monday string. So you can see from here the left will take our data string, start at a position -1, and that will give us everything up to but not including the start of the word Monday. We will then add on the new value, Tuesday. We will then use the mid $command to look at our data variable from the starting position plus the length of the target we were looking for, which is the word Monday. And a return from the function is again the amended data variable. So let's try running that code now so we can compare all three functions together. And there are our three functions now having completed. The replace command is taking 1439 CPU cycles. The second function, the delete and insert commands, is taking 1248 cycles, and the final function, where we're using a string append approach, is taking 1381 CPU cycles. So we can see from this that the most efficient method of inserting a piece of text into a string is the delete insert approach, followed by the string append, and then followed by the replace command. The reason the replace command is probably taking longer to execute than the other two, the replace command is designed to replace one or more instances of the target word. Therefore, having replaced the first one, it will look through the rest of the string to see if there are any more instances of the word to replace. So in code, it's probably doing a bit more than the other two functions. Now, admittedly, the average time it takes to run each of these functions is very similar. There's not much in the way of CPU cycles between each of them. However, if you're performing a particular function many thousands, tens of thousands, or even millions of times, this difference will add up. So if you have a need to do text replacement in a really efficient way because of the amount of replacing you're doing, it's worth taking this approach, measuring to see which one is likely to be the most efficient. Hopefully you'll find this approach useful in your applications, but that's it for today. Thank you for watching.